So we're back in geometry, this time areas again. So a right triangle is inscribed in a circle as shown. If the ratio of the circle's area to the triangle's area is 2 pi, find the smallest angle of the triangle in degrees. So I drew the diagram here. So let our triangle be ABC. Let O let O be the center of the circle. Okay. So I drew ABC so that B has the right angle. So angle ABC is 90 degrees and then AB is less than AC. Okay. So notice that since the triangle is inscribed in the circle, we know that O is on AC, meaning that AC is a diameter of circle O. Okay. And then hold on. Okay. So now let R be the radius of circle O and H be the height from B to AC. So if we draw this, it will look something like this. This is a right angle. So this H. Okay. Then that means that we have the since we have area of circle O equals 2 pi times area of ABC as per the problem statement. You use the formulas, so pi r squared equals 2 pi times 2 RH over 2. Okay. So essentially the this one is 2r since AC is the diameter. Okay. And then you can cancel stuff. You can cancel pi. You can cancel this. You can cancel one of the r's. That will mean that r e equals 2h or h equals r over 2. Okay. Just move this down. Hold on. Okay. So going back. So again, so if we let O be the center and D be the midpoint of arc AC containing B, so basically we want these two to be equal, and then we position D here. Okay. So since H equals R over 2, right? Uh that will mean that B must lie on the perpendicular bisector of DO. So if we draw this and then this, right? This is a right angle and these two are equal. Okay. Then that will mean that DOB is equilateral. Wait, I'll just write that down. Wait. Right. And then okay. And then that will mean that okay. So essentially it's like this is also H and then your R is this and this also R and O OD is also R. Okay, we good with that? Yeah, a lot of people here use trig. It's also a valid solution. I'll present it later. And since triangle DOB is equilateral, side lengths are R. That's DO equals OB uh, equals BT equals R. That will mean that angle BCA, so it's an inscribed angle. That will mean that it's angle BOA over 2, right? So we know that this is a right angle. Angle AOD is a right angle. Wait, I'll just write it. So BOA is AOD minus BOD over 2. So that's 90 degrees minus 60 degrees because 60 degrees because BOD is equilateral over 2. And then this is 15 degrees. And that's our answer. So I'll present the trig solution also. I have to move this down again. Wait down. Okay, there. There we go. So solution 2 is as follows. So if we let 2r be the length of the diameter, so that's AC, and then theta be the smallest angle, okay, then the sides will be, hold on, yeah, then the sides will be 2r sine theta and 2r cosine theta. So this will be, wait, yeah, so this will be AB and no, and BC respectively. Good. Okay. And then that will mean that the area of the triangle ABC is 2r sine theta times 2r cosine theta over 2. So that will be like r sine, okay. So that will be like r times 2 sine theta cosine theta, and this should look familiar because it's equal to sine 2 theta. So you write this. Okay. And then now we use the ratio being 2 pi. So that will mean that wait. So that will mean that pi r squared equals r sine 2 pi 2 theta times 2 pi. You can cancel this. So that means that wait. Oh, this r squared. My bad. And you can also cancel r squared. Right. So that will mean that sine 2 theta is 1/2. And that will already tell you that the 2 theta is 30 degrees, so theta is 15 degrees. And therefore the answer is B. Okay. Do we have any questions? Yeah, okay. So it looks like lots of you lots of you use trig. That's fine. Just as long as you solve it, I guess. Okay.